Hello friends, in my this video I am going to discuss about unity gain buffer made up of op-amp and its application in sample and hold circuit. Okay, so let's try to understand first what is unity gain buffer. If you have already studied linear integrated circuit course, then you might have studied this portion. So to understand the operation of sample and hold circuit, we should have a clear idea in this. Okay, so see, this is the unity gain buffer circuit. Obviously from the name itself it is clear that this amplifier has voltage gain is almost equal to 1, so that it is called unity gain buffer. Okay, see what is that. Obviously in op amp we are considering two pins, positive and negative. In negative pins we are giving the feedback, but see feedback is short circuited with the output side. Okay, so we can say that the voltage arriving in this particular negative pin is equal to nothing but V output, because we are short circuiting this, and in the non-inverting terminal or in the positive pin we are applying V input. Okay, so as you know, the general expression for the output voltage in case of op amp is V output equal to A naught, or the open loop gain for this operational amplifier, into the non-inverting terminal voltage minus inverting terminal voltage. So in this case, if you apply that formula, you will get V output equal to V in minus of V output only, because see, if we go step by step, you will understand easily. V output equal to A naught into V in 1 minus V into, that is the general expression where V in 1 is the non-inverting input and V in 2 is the inverting input, and A naught is the open loop gain. Now see, for this particular circuit, V in 2 or inverting input is nothing but V output, and V in 1 or non-inverting input is equal to nothing but V in. Now you replace that in this particular expression and you will get V output equal to A naught into V in minus V out. Now you multiply or just take some simplification steps. You will get V output equal to A naught into V in minus of A naught into V output. Take this particular term A naught into V output in the left hand side and you will get V output plus A naught into V output is equal to A naught into V in. Take V output common in the left hand side and you will get V output into 1 plus A naught is equal to A naught into V in. Or you will get V output by V input, or the voltage gain for this particular op amp configuration is A naught by 1 plus A naught. Now as you know, open loop gain for op amp is very high, so A naught approximately suppose 1000 or any very high value. If you take, what happens, just observe. Suppose let us take very high value as 1000, just for example purpose I have taken. You can take any high value and you can put this approximation, that is V output by V input is equal to 1000 by 1 plus 1000, which is almost equal to 1. If you calculate exactly, it will come as 0.99 something, but if you take approximation, that is almost equal to 1, so that we can say that as A naught is very high, from the expression also you can say that if A naught is very high, 1 plus A naught is almost equal to A naught, and A naught cancel each other in numerator and denominator, and we will get V output is almost equal to V input. So for this particular circuit, whatever we are giving in input, we are getting as output. So this is called unity gain buffer. Okay, or the voltage gain for this particular circuit is 1, or we can say this is voltage follower. Output follows the input voltage. Okay, so what may be this application of this particular circuit? See, if you want to isolate input and output with voltage gain 1, okay, that is, you don't want to amplify or attenuate voltage, but what you want isolation in between input and output side, we can simply use this circuit. Okay, because as you know, from the input to from the positive, this, see, observe this non-inverting input, from non-inverting terminal to output there is no connection. Okay, so basically for isolation purpose we can use this. Like suppose in VLSI you might have studied pass transistor logic. Just have a quick recall. MOSFET as switch already you studied in VLSI or in digital logic design circuits in detail. So here this is one NMOS switch I have taken, where in gate we are this is called control signal phi. If gate voltage is greater than VT or threshold voltage required for the particular MOSFET, then the MOSFET will be turned on. Then whatever voltage we are applying in the drain, that will go to the source. Okay, so V in is basically almost equal to V output. Basically, as you know, NMOS passes weak ones, strong zeros. That is also okay. But generally, if you take the rough idea, if this phi or this gate voltage is greater than threshold voltage required for the particular MOSFET, then in between source and drain one channel will form, and the voltage applied in the drain can go to the source. Okay, so basically V in will pass to the output side, or drain voltage will pass to the source voltage if we apply gate voltage greater than VTH required for the particular MOSFET. Okay, in this way NMOS VS like switch. For detailed explanation you can search in Google that NMOS pass transistor, and you can get a detailed explanation on that. Okay, now suppose what we do in the drain side, we are applying V in as suppose one AC signal, and in gate here I have drawn in gate we are applying one pulse signal or one square waveform. Okay, so what will happen? So when the applied gate voltage is VDD, then V input will be passed to the right hand side from the left hand side, and when gate voltage or the particular square waveform is taking voltage as 0 volt, then the MOSFET is turned off, then no voltage can go from the left hand side to right hand side. Okay, so basically in this way sampling can be done. Just if you observe this particular AC waveform, suppose this is our input waveform and this is applied pulse or applied square waveform in the gate or control voltage. So what will happen? See, when gate voltage is VDD, then the MOSFET is turned on, then in the output side or in the right hand side what you will get? See, this particular part of the input voltage will be passed. Okay, so that it is called pass transistor also. See, it is passed. See, this particular part, if you zoom it, this particular part looks like this particular part of the input waveform. Then again here if you observe, in this part the control signal is 0, so that MOSFET will not conduct any voltage. Okay, so what will happen? So basically here you will get 0 volt. Then again see, here we are applying again square pulse, so this is V gate voltage is equal to VDD, so MOSFET is turned on. So what will happen? This corresponding to this particular square waveform, the input voltage is this. Okay, see here this particular input voltage is passed here. Okay, like this you will get this kind of waveform in the output side. So this is called sampling, right? In your analog communication course, you already studied pulse amplitude modulation or natural sampling, flat sampling in detail. So this is from the basic idea of communication engineering, you can say that this is sampling we can do like this. But see, this sampling pattern, when the control voltage or gate voltage for this particular NMOS switch is VDD, then input is passed to the output. But when the gate voltage is 0, the output is going to 0 volt. But suppose you want to hold that particular voltage. Suppose in this, when the control voltage or gate voltage is 0, suppose you want to keep your output voltage as this voltage only. That is, suppose you want to make this kind of waveform. See how this waveform looks like. See, here the output goes like this. Okay, and here it ends at this particular voltage. So when applied gate voltage is 0, suppose you want to keep your output voltage at this particular voltage only. So what will happen? See, this kind of straight line you will get. So this is holding that particular voltage if you want. So this kind of waveform you will get if you apply, sample and hold both concepts simultaneously in the output network. So what will happen? Suppose you want to hold a particular voltage, what you can use? Just try to think. Obviously correct if you think that is capacitor. Okay, in your basic physics course you have already studied that capacitor can store charge, hence we can store voltage for particular instant also. Okay, but we have to make the capacitor such that there is no way to discharge the capacitor. Okay, that we should keep in mind. So what we can do, suppose we, after sampling, we want to hold that particular voltage which the output reached at just before control voltage goes from VDD to 0 volt, the output voltage reached suppose 5 volt. Then if you want to keep the output voltage at 5 volt only throughout the region when the control voltage is equal to 0, that is, if you want to implement sample and hold circuit simultaneously, what we have to do, along with the NMOS switch, we have to use one capacitor CH. Okay, because this capacitor, when you apply phi equal to 0, 0, that is when control voltage is 0, that is the NMOS will be off. So what will happen, or you can say the switch is open, so no input voltage can go to the output or right hand side. So capacitor will hold that particular voltage where it reached just when the clock or the control voltage goes from VDD to 0. Okay, that is, it will hold the last voltage where the output reached. Okay, so this is called holding capacitor or hold capacitor. So this is denoted by CH. I hope it is clear to you. Now suppose you want to measure the voltage. How you can measure this? Obviously you have to measure the voltage across one resistor, but the problem is if you directly apply one resistor parallel with this capacitor to measure the V output, what will happen? Suppose phi equal to 0, that is the if the NMOS switch is closed, if the switch is open, that means no input voltage can go from input to output side. So capacitor is holding that particular voltage, but in this particular circuit what will happen? It cannot hold that particular voltage because it has one way to discharge its voltage. The voltage or the charge will go from capacitor, this positive plate, if you consider this as positive plate, it will go via the resistor to ground. So as a result, what will happen? It is unable to hold the particular voltage. So what we can do, we have to make we have to give certain circuit in this particular region, that is in between capacitor and resistor, which has no voltage gain, that is unity gain, or which can act like voltage follower, but it will isolate in between input and output, but it will pass the input from input to output, it will pass the voltage. So what we can do? Simple, we can use that unity gain amplifier or unity gain buffer, which we discussed using op-amp just in the initial of our this video discussion. Okay, so what we can do? Simple, this circuit we can implement. See what will happen. So when phi not equal to 0, that is we are when P control or the gate voltage is equal to VDD, that is this particular NMOS switch is on, the input will simply pass to the capacitor or in the right hand side, and you will get voltage across the resistor. Simple. But when this phi is equal to 0, okay, so what will happen? This NMOS switch is open circuit, so no voltage can pass from input to the output. So capacitor will hold that particular voltage. It cannot find any path to discharge because in the left hand side phi is 0. So this is open circuit, and in the right hand side also, see, this has this basically open circuit, right? Because op-amp there is no direct connection in between this positive non-inverting terminal and the output. So here also no path to discharge, but the voltage which you are getting across the capacitor, the constant voltage, or we can say the hold voltage, can go to the resistor, because we have studied whatever voltage we apply for this unity gain buffer in the non-inverting terminal, that will go to the right hand side or in the output side, that is V input in applied in the non-inverting terminal is equal to V output, which we can easily get across the resistor. Okay, and see one more thing, this kind of concept is very important. See here I have drawn square pulse exactly, that is it has 0 rise time, 0 fall time, but in practical it is not possible. Obviously like if you simulate in cadence, you might have done VLSI lab experiment in cadence, we give what, some small rise time and fall time, right? So basically in practical, if we implement square pulse, always try to give this kind of square pulse which looks more practical. Okay, it has certain rise time and fall time. Okay, so this is also very important point. So this is how sample and hold circuit works. This particular circuit, only NMOS pass transistor can act like sampling network, but if you want to hold, you have to add one capacitor. Now if you want to take the output, obviously you have to connect one resistor parallel with the capacitor, but if you directly connect resistor, it will the whole voltage will discharge through the resistor. To overcome that, we are applying one unity gain buffer. Okay, so this whole circuit is basically sample and hold network, which has very important application and huge application in communication engineering and electronics engineering. Okay, you should have a clear idea in this particular portion. This is all for this video. If you have any doubt, you can ask in the comment section. Just you require some basic concept of op-amp to analyze this circuit, and you should have a clear idea in MOSFET pass transistors. If you know this too, this circuit is very simple. Keep this circuit in your mind. Sometimes in interview also this circuit may ask in your technical round or in your aptitude examinations also. Not aptitude examination, like in technical MCQ based examinations also this question may appear. Okay, this is all for my this video. Thank you for watching.